We're going to figure out what it means when we have exponents that are zero and when we have exponents that are negative. So we're going to start with figuring out what it means when our exponent is zero. So I'm going to use the quotient rule. So I'm going to start with using the quotient rule. And the quotient rule means that I keep my base and I subtract my powers. And that's going to give me a to the 0. And I'm going to figure out what that means when I start looking at the ratio or the fraction of a to the 5th over a to the 5th. So we're going to look at this in another way by expanding it out. And I'm going to say, well, this is really 1, 2, 3, 4, 5 of these on top. So a to the 5th on top. And on the bottom, I have 1, 2, 3, 4, 5 of these on the bottom. And we know that anything over itself is 1. So if I have like 2 over 2, this is 1, right? 1. And 3 over 3 is 1. And 7 over 7 would be 1. Or a over a would be 1. All of these things are equivalent to 1. So I can reduce this ratio and say, well, this fraction, and say, well, a over a, well, that's just 1. And this a over a, well, that's just 1. And when I reduce these, it's just 1. And these, it's just 1. And these, it's just 1. And when I multiply the numerator, I have 1 times 1 times 1, like 5 times. And that's going to be 1. And on the bottom, I have the same thing. When I multiply 1 5 times, I get 1, and 1 over 1 is 1. Okay, so we know that if we reduce the fraction, because we have the same thing on top as we do on bottom, that it's going to reduce to 1. So that means that right here, when I have a to the 0, anything to the 0 power is 1. So we're going to write this rule and say anything to the 0 power is 1. That's my rule. Okay. All right, so that's the first one. The second one I'm going to do is dealing with my a to the 5th over a to the 7th. And I'm going to do the same thing I did before. I'm going to expand this guy out. So I'm going to say, well, let's expand this out. And say in the numerator, I've got 1, 2, 3, 4, 5. And in the denominator, I have 7 of them. So it's 1, 2, 3, 4, 5, 6, 7. Okay. And I'm also going to use the quotient rule. So we're going to say, well, let's use the quotient rule. My quotient rule. And that means I subtract my powers. So I keep my base of a and I subtract my powers. And that's going to give me a to the negative 2. Okay. So when I expand it out and I look at it in terms of ratios of 1, I'm going to reduce my fractions, reduce my ratios, and say, well, that's just 1, and that's just 1, and that's just 1, right? I have anything over itself, right? That's just 1. But I don't have any more for these two on the bottom. But I can multiply my top and I go 1 times 1 times 1 times 1 times 1. Well, that's 1. And on the bottom, all these 1's times a, well, that's just going to be a squared. Okay, so what I can do from this is I can say, well, what does it mean when I have a negative power? So when I'm looking at this guy right here, and I said, well, when I did the quotient rule and I ended up with a negative power, and I compared it to us doing the same thing logically, but getting it in the denominator, that means that the negative power is notation. So I'm going to write down this rule and say this negative power is notation for move it across the fraction bar. Right? That's what that means. All right, so there's my rule. Because a to the negative 2 is the same as 1 over a squared. So make sure I'm going to write this down in red. Make sure we write it with a positive exponent. Because when we moved it, right, this guy down here, he didn't have a negative exponent. Okay.